So yes, my name is Sean Larkin. 叫我小恩拉金. I speak a little bit of Mandarin. I'm trying my best. I'm learning every day. So, feel free to criticize if I'm saying things wrong. But I'm a technical program manager at Microsoft. I work on Microsoft Edge dev tools. But I think most of you know me as one of the maintainers of the Webpack open source project. So I have advocate on this slide because there are many maintainers on our project. Even people who never touch the code base itself, but are working on triaging GitHub issues. They're helping people on Twitter. And so I play a role of both the maintainer of the entire organization, which has over 100 GitHub repos across 2 organizations, as well as our documentation team, our cultural teams, such as Webpack China. Like, who here is involved in Webpack China that I initially reached out to? Raise your hand. Like, stand up, actually. Please stand up. Like, these people today are why I was able to come here. Thank you. Thank you very much. You can thank them for the Chinese documentation of the Webpack docs. But I'm also, I brought Webpack to the Angular ecosystem. So I was on the core team working on the Angular CLI, and now kind of just a general evangelist for open source sustainability and how to have more sustainable open source projects. So a little bit about myself is that I am a tech support rep gone rogue. So I did not go to college for software engineering. I did not go to, I didn't study computer science. I actually studied music and choral studies. And one of the things, after I graduated college, I just wanted a stable job. So I was doing like customer service on the phone. But I got so tired of not being able to solve people's problems. And so because of that, I started to teach myself how to program. And so it first started with AppleScript, and then Ruby, and then eventually Swift, and then JavaScript is where I fell in love with JavaScript. And really, I'm trying to build more communities and ecosystems today. So like if you go to any of these websites or have a VPN to access them, you can find me at the Larkin. And then also on Weibo, I'm at the Larkin as well. And so if you didn't get to ask me something, you can always go to my GitHub, thelarkin/AMA, and you can ask me any question that you want. It can be personal, money, life, like work related, it doesn't matter. And then I also want to give a shout out to a contributor who helped me add some Chinese translations onto these slides. So there are some technical topics that I did not have the right translations for, and I wanted to thank him. He's a huge contributor in the TypeScript ecosystem as well as the Vue.js ecosystem. And then finally, our backers and sponsors. So today, our project would not be where it is today. There would not be a Webpack 3. There may not be a Webpack 4 if it wasn't for funding to support our project. So especially our #1 sponsor, which is Trivago, and you can see their logo right here. They actually talk about what it would be like, or what sponsoring our project has done for them. So today, because they're our major sponsor, their logo shows up on our GitHub and on our documentation page. And they link back to their job, their job hiring pages. And because of that, 90% of their JavaScript engineer positions were hired because they came from our pages. So Trivago is one example of a company that found a huge value in sponsoring us, not only because they want to support the project, but they get something instantly in return, which is great engineers who want to work for their company. And there are even companies who are in the Chinese market I think like Strikingly is the English, but they sponsor multiple projects, including Webpack and Vue and Babel. So now to the talk. Like I said, there's 3 goals that I want to really have you walk away understanding. So like we're going to walk a little bit through the Webpack source code today. And we're going to understand what a plugin, like the anatomy, how is a Webpack plugin made and what does it look like? And then give you ultimate power. Really the idea is that if you understand how Webpack works under the hood, you know how to leverage its greatest power, which is extensibility. The ability to extend any piece of the software itself. And I mean, there is a secret incentive that we have, and that's we want your help contributing to our project. We want contributors, and not only does it help you better understand the software, but it helps make our product better for everybody else, including your own company. But before we begin and talk about Webpack, we have to kind of talk about the single JavaScript library that is the backbone of the entire system. So, Tappable. Who has heard of Tappable? If you've heard of it, just raise your hand if you know what it is. I see a lot of Webpack China people raising their hands, and others. So Tappable is the plugin library for Webpack. It started out as a 200-line library. It's now grown a little bit larger with Webpack 4 because we rewrote it from the ground up. It is the backbone of the entire plugin system. It is very similar to Node.js event emitter. And so here is an example of the original V1 or V0 plugin system. So if we look here, we can tell that there are, I'll use the mouse. There are methods that when you extend this class called tap, or you extend a class to use Tappable, you are giving the class that you extended extra methods called apply plugins parallel, and there's a variety of them, and inside the function call is the string or the event name that is going on or triggering. So this is how plugins would listen to these events and then perform additional functionality in Webpack. Here would be an example of a plugin that would listen to one of these events. And mind you, this is the Webpack 3 or original version, and I'm going to show you an updated one as well. But this is the basic plugin, and you can see the anatomy of a plugin is that it just has to have an apply method, right? And what this apply method does is this is how the Webpack passes in events or objects that can be listened to. So in this case, the compiler is passed. Listen to or call functions like .plugin to listen to these events like make or build or error or finished. And so this is an example of one of these plugins. But did you know is one of the most amazing things, let me see if I have it. If I don't have the slide, I'm just going to pull up an example. There's nothing wrong with doing that. Oops. Is that Webpack itself is built entirely out of plugins. So if you were to look in the Webpack source code, you would find out that just looking at the examples of this source, I'm just going to show you the sidebar. That's what's important here. Is that these are all of the files in the Webpack source code. Almost every single one of them are plugins. So all of Webpack is an event-based system. And each of these plugins are just listening to different events. And we'll look at that briefly. So this is an example of one. Now, if we look at Webpack 4, we rewrote the system. Instead of having event strings, now they are static events. So they're properties that live on this, what we call a tappable instance. And so the compilation here is calling a hook. We call them hooks now instead of events. And here is an example of a plugin to the right that is listening to those events and tapping into them. And then here is just a more, just a single example of a Webpack 4 plugin, which still has an apply method, still receives a compiler, but instead the API is static. And so now you can see that you're accessing the name of the event here instead of a string. And so there's a lot of benefits, like being able to have typing support. If you look at this screenshot, this is not TypeScript. This is JavaScript, but we're using a custom-made VS Code plugin that if there is IntelliSense, or I'm sorry, if there is JS doc annotations, it is reading and assigning that type to this parameter and then creating and inferring all the types from it. So this code looks like TypeScript based on these comments that are decorated on the source code, but it's not actually TypeScript, it's just JavaScript. Our code base is now being annotated with JS docs that you see here, and we use the plugin to make it look like this is TypeScript. So, and you can ask me about that later or another time. So, when I say a tappable instance, what does that mean? All that is a class or an object that extends this library called tappable. Or in other words, it's something that you can plug into. So, and to go even further, there are some plugins that you must actually, there are some tappable instances that you have to plug into to be able to access others. Let's see if this will show up. Maybe. It hasn't changed yet. Oh, there we go. Okay, okay. So here's an example of just a drawing where you have to access the compiler to reach the compilation. And so there are some systems where you have to reach one to access another. So what we're going to talk about today are these seven tappable instances. And by the end, you're going to understand how Webpack works under the hood completely. So the first one is called the compiler. If you're familiar with a compiler, just raise your hand. It's like if you've written a compiler in school or had to like work with one. An example of a compiler is like LLVM or Clang. We have a class in Webpack that's called the compiler. It's a tappable instance, and you can consider it as like the central dispatch, or kind of it is the top level instance responsible for being able to start and stop the program, catch errors, bubble up events. And it's actually what you use when you expose the, or when you use the Node API with Webpack, you're using the actual compiler instance. And here's an example of that, where you might require Webpack, you pass in your config and call Webpack. That is the compiler instance that gets returned. The second is called the compilation. I couldn't find a really good translation for this one. But the compilation is responsible for generating the dependency graph. And so I like to call it, like, it is the brain. It is the most computationally intensive piece of Webpack. It is responsible for collecting all of the dependencies and building out the graph and tying relations together. Or I would say it contains the dependency graph traversal algorithm. And then the next instance is called the resolver. So the compilation, let's say, for example, you're going to start out with an entry point in Webpack. That is the first file that's going to kick off your application. And so what will happen here is that a module factory will grab your entry point, right? And you have a period / foo.js. But if you remember, this path is not resolved yet. So like, you don't actually know if this file exists on your file system, and neither does Webpack. So what the resolver has to do is it takes this partial path and it goes and searches for it. So as you can see here, it says, I'll find it. So it's going to go look and make sure that this file exists, and then it's going to return back the absolute path, and then additional information like the context, like what's the root path, or what directory was this folder in, or I mean, this file was in. And it's also it's tappable, right? These are tappable instances, and so by default in Webpack, this is a separate library that you can use on your own called Enhanced Resolve. And it already has a bunch of plugins built for it. The next is called the module factories. So if you've ever written Java, you know what a factory is, right? It is something that creates objects. Typically in JavaScript, they're just functions that return objects. In this case, we call them module factories because it is responsible for creating a module data type inside of the source code. So what the module factory does is it takes a successfully resolved request, right? So that extra information that the resolver creates for it. And then it actually collects the source, the actual source code for that module, right? So for example, this information we got from the resolver, and we're going to pass it through the factory. And then the module factory is going to create this instance that not only contains the source code, but it also contains the file name and additional information. And it's so beautiful. And then finally, the second to last instance is called the parser. So if you've ever used Babel, you've used a parser. If you've used Webpack, we have a parser ourselves. It's called Acorn. The parser in Webpack is really special because it's responsible for helping create your dependency graph. So what does a parser do? It parses. It takes the JavaScript source that your module is made of, and it's going to create an AST out of it. And it will then walk that AST and look for imports and requires and dynamic import statements. And for every single one of those statements, that means that there is another file that this current file depends on. And so we attach a reference called a dependency. You can think of this as like a node and an edge on a graph. In a graph data structure made of nodes and edges, the dependency is the edge that points towards another module. So in graphical terms, you can see here that we have our module instance, and the parser is going to read the source code for it. And for every single dependency statement, like an import, it's going to attach a reference or an edge to that node because we're going to need it. And then finally, the template. Now, I was told that this definition here is very generic, right? Because template in itself is kind of generic. What does a template do? It allows you to take data and bind it to some sort of creation of that, like representation of that data. So an HTML template lets you take data of some sort, like state, and then render that state into some sort of form of UI. So a template for Webpack, though, is data binding for your modules, or data binding for the dependency graph. There are many types of templates, but it's responsible for generating the code that you see when Webpack runs. So an example of this would be, if you look here, there are many types of templates for each abstraction that we have in our source code. So we have a chunk. A chunk is basically a collection of modules. Typically, we take the graph and we flatten it, and then we put it into a container called a chunk. There is a template for every single type of these abstractions that you see here. So we have a main template, which is for the Webpack runtime code. We have a chunk template, and then for each of the modules, there is a module template, and then each of the dependencies, there is a dependency template. And each dependency can be a different flavor or mutation. So a require statement and an import statement have two different purposes. And so their rendered code is going to look much different. So when this actually renders, this format probably looks familiar to you, right? Like this is what a Webpack generated bundle looks like, right? And each of those templates is responsible for generating one piece of that created bundle. So if we break it down now, I have in order created a story for you. So starting with the compiler, Webpack is going to run. It's going to receive the configuration, which is just props. Think of them like props. And it's going to take the entry point, and it's going to pass it to the normal module factory. It's going to say, hey, take this entry point, or this file path, and let's create a module for it. Well, it doesn't know if it's resolved yet, so it has to pass it to the resolver. The resolver is going to collect and make sure that that exists, and it's going to return it back. And now the module factory can collect source code for it. So now what happens is that we can pass this source code to the parser, and it's going to look for any dependency statements, imports, requires, require.ensure, dynamic import statements, and it's going to attach a dependency to it. But once you get to that point, now you have technically dependencies have a path, right? But they're unresolved. So now it's going to repeat this exact same step for every single dependency. So you can think, for each dependency, take the path that's referenced and run it through the exact same process. So this is what we call a breadth-first search recursive graph traversal algorithm. Hopefully did that, maybe, I hope that actually. A breadth-first search recursive graph traversal algorithm. Breadth-first search, recursive graph. Good, okay, I hope that makes sense, especially what I said right there. And I actually want to just write it in code for a moment. So let's say, for example, I have just a very simple project here, and we'll hide the Webpack source code. But let's say we have some class, right? So if I was to diagram this simple graph, it may look something like this. We have our entry point, which is going to be like, let's say, index.js. I'm going to just put this down for a moment. So this might be an example of what this graph would look like, but you start out with an entry point, it resolves it, and for example, we would see this import statement here. That means we would create a dependency, but we need to still verify that this exists. So we would resolve that, collect the source file, but now we can actually create a module for it. So this is kind of how the graph would look like if we were to diagram it in some way. And if anybody wants to create a cool data visualization for this, feel free and do so. There's many that exist out there today, but I think that we're still lacking some really cool looking visualizations that tell a story about how your application is shaped. So now that this is just one part of how Webpack works. This is the creation of the graph and collection of your source code. So here's the next part, and I've written it as like a comic strip, right, or a story. So it starts out like this. Hey, I'm a module. I can't wait to get into the browser. But the compilation says, whoa there, cool your jets. You need to wait. We need to get you ready for the big stage. First, we need you to jump in this container called a chunk. We'll be throwing lots of plugins at you to optimize you, and we don't want to lose track of where you are. And we're almost there, But there's a problem. The require and import statements that you have must go. They don't work in the browser. So the parser gave us special instructions called dependency templates and dependency factories. This is going to allow us to have browser-compatible code for your modules. And then you can see here that it's been rendered. So finally, I'm ready for browser land. Let's go. So that is how Webpack takes and renders the actual graph itself through these template system. But if you take a step back, you just learned entirely how Webpack works. That is the entirety of what Webpack does as a system. It builds the graph. It takes the data and just renders it. What I've challenged, so I've challenged people before, and I said, you should make a JSX version of a rendering system for Webpack. Use JSX to do it, right? Because you're just receiving props, and it's just going to generate strings, which are your bundles. But that's exactly how Webpack works entirely. But you might say, Sean, why should I care? Like, why does it matter? Why? I think for me, it's if you understand all of the tappable instances, right? So what does that mean? It means that now you understand how to plug into any of those things. When you understand their purpose, you can now augment and extend their behavior completely. And if that's not enough, I have even more examples or visual guides to learn how the Webpack source code works. So to give this talk, I had to learn and read every line of the Webpack source code because at one time, I had no idea how it worked. So I had to learn it myself. And so I created a repo on GitHub called Artsy Webpack Tour. And I'll show it to you. Well, I don't know if I can pull it up myself here, but if you go there, you will see that it is a collection of screen captures that, of our source code that I have annotated. And these annotations will guide you through the entire source code itself. But like I said, every instance that I've talked about today can actually be plugged into. And so therefore, anything can be extended. Literally anything. Even the file system itself. And so if you want more learning or you want to be able to walk through something that is a bit more hands-on, we even have, or I've created a GitHub repo that allows you to do it as like a workshop with Git-based lessons. And so it's called the Larkin / everything's a plugin. I would love a PR that upgrades this from Webpack 3 to 4. But I created it just before we switched. But the concepts are still the same, and the purposes of the instances are still the same. And I also want to showcase or give you an example of, we're going to walk through an actual real live plugin that somebody in this audience has created for a project called Google Summer of Code. So Vincent, will you raise your hand? Yes. Vincent here. What's really awesome and kind of a special opportunity is that Vincent is one of the Webpack project's Google Summer of Code students. So he was awarded the opportunity to be paid as a summer internship to contribute to our project via Google. And so his project was called Deep Scope Hoisting, or Deep Scope Analysis, correct? Did I say that? Yeah, Deep Scope Analysis. But what are the implications, right? Like, what does this work mean? And so I'm going to show you an example that I created today. You can see here, this is a very small project. It only has 2 modules, right? And there's a very simple Webpack config. But you can see here the plugin that Vincent wrote is called the Webpack Deep Scope Analysis plugin. And this is the NPM module for it. But by simply adding this plugin to your configuration, well, I'll show you the before, and then I'll show you the after. So let's just specify mode so it doesn't yell at me. Production. All right. Well, actually, let's leave it out. I'm going to leave it out for now. Okay, so if we look here, there is a class that we're importing, right? And we're using that class, we're instantiating it, creating an instance of it. Sorry, functional programmers, I know, it's classes. And then we're just going to use one of the methods that's on this instance, right, called message. But if we look at the implementation of this class, what is important here is that we also have another method called makeUnique. And really all it is just a method that is using the unique function from Lodash. The point here is that we have this function that we're not using, but it creates a dependency that has some sizable amount of code. So if we run Webpack, Webpack 4 as it is today, and we run it, we will see here that observe the size of the bundle, right? 6.42. And that's not huge, right? This is automatically in production mode because Webpack by default, if you don't pass one, you can see here it falls back to production, okay? But let's add the plugin and see what it does. So traditionally in Webpack 4, one of the constraints is that we are only doing tree shaking at the module level or the module boundaries. However, in a situation like this, we have a class where we're not using a method. Why should we ship this code if we're not using it, right? And so we can infer this because we're looking at our entry point and it's not used. So we can safely assume, well, today you would say like, Webpack today though cannot remove this function, right? Because it's not a module export. This is at the statement level, tree shaking. So what this plugin does, I'll let you just observe it by uncommenting it. Let's run it again. And look at the size of the bundle. Oh. So that instantly removed the unused method, right? So this is providing a capability that Webpack could never do before, just by this plugin. So one, if you want to give like Vincent a round of applause, like this was really good work. But I'm going to now take you through the plugin itself, and we're going to read actually what it's doing. And we'll just walk through it. Is this transpiled with Babel? Oh, good. Okay, good. It would just make it hard to read if it was. Webpack Deep Scope Analysis plugin. So let's see. Very nice. Okay, so as you saw before, so there is so how this capability works is that there is a library called ESScope. And you can correct me at any time if I'm wrong. I was not Vincent's mentor for this project, but Tobias, another maintainer, was. But I've been reading about it, so if I say something wrong, he can feel free to correct me. So we can see here, we have the apply method. So that's like the one rule for a Webpack plugin, right? So we can now, understanding what each purpose of these tappable instances, we can technically look through this code and get an idea for what is happening, right? So we can see that we're tapping into the compilation. This is how, and we're going to access hooks from it. So from the compilation, we're looking for dependency references. So this is I think this is a new hook that we added in Webpack just to support this feature. But essentially, it's any time that we come across a module and we parse it, we are also storing the state of where that dependency is and what it's referencing. And so therefore, we're plugging into that event, and we're going to check what kind of type it is. We're going to say, well, is this an ES6 import? Then we're going to use this module scope analyzer to analyze the different pieces of it. We're going to look at the used exports, and we're going to track them. And then we're also going to check some other conditions, like are there namespaces used? Is there an ID for this import or export? And then it's going to go through and track this information. And then we're going to hook into the parser itself, right? So the parser, remember, it creates an AST, and we can access that entire AST. You have the ability by tapping into the program hook in Webpack. And so this is actually tapping into the parser for every single module's source code, and it accesses the program for it. And that returns an AST here. And what we're looking for, so essentially what's going to happen is it's looking for different resources and the resource name, and it's passing it to this module analyzer. And it looks like the analyzer itself can take an AST, and it's going to be able to identify where there can be stronger or deeper statement level based tree shaking. And so, but if you look, that is the entirety of the Webpack plugin itself. There's 3 tappable instances, or 4, the compiler, the compilation, and then the parser itself that are being accessed. And so something like this is entirely possible without even having to change Webpack. We've been able to do this just by creating a plugin, third party, and adding it. And so not only the benefits of a system like this mean that we can easily pivot, or we can easily add or remove features that are incredibly powerful. Now, every decision comes with trade-offs, and so if you've ever worked with event-driven architecture, there are trade-offs to it. But these are some of the huge benefits. Another thing that I want to show you as part of the Webpack source code is the actual, one of the largest examples of how we encapsulate or use plugins to separate behavior in Webpack. So there is a file in our source code called Webpack options apply. So technically today, you might say like, Sean, let's say we're gonna create a hypothetical scenario. Sean, I want you to drop CommonJS support because CommonJS is the root of all evil. Okay. Well, you could easily create this PR because every single feature that we support in Webpack is isolated with a plugin. So, do you want to should we drop CommonJS? Okay, we've done it. We just dropped CommonJS support in Webpack, just like that. That's how you would do it. Do you want to drop using system.import? Okay, we just did it. Do you want to not support AMD modules? Okay, it's done. So that is how it's that easy for us to be able to drop or add a feature because they're completely isolated. And they know nothing about each other in itself. But this is a great file to actually start out if you want to learn more about what the capabilities are. Now I could spend a bunch of time like looking through these individual plugins, but I don't think that you're not going to know when you want to write an integration for Webpack until you actually need it. So this is a great resource that you can use. And if you want to see how you should write a Webpack plugin, go to our source code and look at one of these plugins. Because all of our source code is using that same system. So if you want to see the best practices, look at our source code, and it is a manual or instruction guide for how to do so. So if there's some other things that, let's say like, Sean, I want to help out your project, but or how can I do so, or where can I start? It goes beyond just like submitting PRs and everything. So if you want to come help us, at the end of the day, like I said, it's to not only empower you, but to help empower us at the same time. So you can help us by triaging GitHub issues. We have an entire organization that's devoted to maintaining our core loaders and our plugins. So let's say you just have an interest in one plugin. You can help us maintain it, and we have a strong interest in that. You can contribute to our new documentation. And include, so any of the people who raise their hand that is part of Webpack Guangzhou or Webpack China, you can go and help contribute to the Chinese documentation if you'd like, instead of the English documentation. And like I said, you can go to Webpack Contrib, which is the organization. And then finally, not Webpack 2. This is, at the end of the day, like, this is what we say. So if you want to help support the kind of the overall effort. There we go. Ooh, sounds like a lot of water. It's like, what is that? You can, if you want to help sponsor, you can speak to your work or your boss and say like, wow, we really want to have, to be able to support the project, or have Sean come on site and do like a day workshop. You can become a sponsor and we'll generate a contract for you that is easily expensible. And that can be part of sponsoring our project on Open Collective. So at the end of the day, it's meant for you to be more empowered, but it's up to you whether or not you want to extend or use the system. And now you have that power at your fingertips. So you can always find me, like I said, at the Larkin. And if you're on Twitter and Weibo, I do search Webpack, #Webpack. So if you have like questions or concerns, or you're frustrated, you can always just tweet out or send a Weibo, and I'll be able to see it. So thank you.
好 ，Thank you。大家有什么问题吗？我们可以这里。
Okay. I have a question for you. There are many generators for projects such as Create, React, and Vue.CLI. They hide Webpack configurations very deep, and we can hardly modify the configuration of Webpack. So, what do you think about this?
So I think that there are two it's a spectrum, right? So it's a matter of opinion. Go this way? Oh, okay. So there are people who believe you should never have to touch a Webpack configuration, right? Angular is a great example. Do I think it's the right decision from my opinion? Maybe not. However, Create React app is another example, but at least they let you eject. In my opinion, I think something like what Evan Yu or Yuda does for Vue.js is that it not only allows you to have the configuration abstracted, but when you need to modify it, you can do so freely. So I think that is the right balance between extensibility and ease of use. So I think that's kind of the best way that or like the most powerful way that you can let people who are just getting started not have to worry about it. But if you want to have something like extra capabilities or custom plugins or anything, you can do so by customizing the configuration. Even like the Vue CLI has this CLI service which allows you to write a plugin that augments the Webpack configuration. So like this is something that we're looking to add as a primitive in Webpack itself, which is like presets. How could we take the fact that we have a 0 configuration default, but if you want to add features, do you have to do it by modifying the config? Or could we have a preset that you could just install and then it does it for you? So that's kind of the path that we're trying to go towards. But we're waiting to see how other frameworks are doing it. So like waiting to see how Vue CLI did it gives us a lot of insight that we can learn from and maybe adopt those things so that it means if we add those primitives, then it's a lot less code for the Vue CLI service, right? Because now it's just a capability we provide out of the box. Thank you. 谢谢. Are there any other questions?
还有其他问题吗？如果还有其他人有问题，可以提前示意一下。
I'm curious about the custom plugin you mentioned before.
Yes.
How does this work? Is it just display the JSDoc in another position, or it's magically add static typing according to JSDoc?
Yes, so the typing that it's providing is actually powered by TypeScript. It's a TypeScript feature. So using allow.js, you can automatically get IntelliSense for your project. So like, for example, if I actually pull up the Webpack source code, which I'll just do it. I'll pull up the source code here and we can see the example. Might take a second here. I think I have this plugin installed. I believe so. Entry option plugin. Yes. So the plugin itself it's open source, but you have to build it yourself locally on your computer. Am I using insiders? Oh, I might have. So I have it on my other computer, but the examples are that, let's see. Essentially what it would do, so right now, here, I'll show you this. So in this project, I'm not going to talk about the plugin yet. I'm just going to talk about the TypeScript feature. So in Webpack, in our source code, if you clone it, you're going to see that now we've added a whole bunch of type annotations. The reason why is because now I can run yarn type lint. And as you can see, it just runs TSC. So it's running TypeScript. So we're using the TypeScript type checker. And as you can see, there are no errors. But this is type checking our entire code base. It's type checking all of Webpack without having to have a build step. We want, which is ironic because we are a build step for the front end. But this allows us to be able to write JavaScript without needing the .ts extension.
Oh, thank you.
And then the
不要在这个交流了，不好意思，就是你等会儿可以在休息时间跟他交流。
No, it's okay. It's fine. The plugin itself just takes that information and inlines it as a decoration onto the JavaScript. So
thank you.
It makes it look like TypeScript.